Hello everyone. In this video, I'm going to talk about how to estimate the population mean. And in the next video, I will talk about how to estimate the population proportion. But I have both topics in here, okay? So that's what we're talking about in these topics. In chapter 8.1 and 8.2, we discuss how to estimate the population mean mu. And in 8.3, the discussion is about how to estimate the population proportion. So in this chapter, we are thinking about questions such as this. What is the average age of all state students? That's a question that seeks to estimate the population mean mu of the ages of all state students. Or if you're interested in figuring out the percentage of Canadians that will vote for the Green Party in the next federal election, then in that case, you are thinking of estimating little p, right, which will be the population proportion of voters who will vote for the Green Party. Or if you're interested in thinking about how big your sample size should be in order to estimate the true population proportion of drunk driving fatalities in Canada, for example, then you are thinking of estimating little n. Okay, that one is in 8.5. Okay, I'm not sure if I will be able to get to that one, but in case I do, that's what that would be. But for now, we are going to be talking about estimating mu, population mean, and population proportion. Okay, so when you are estimating the population mean mu, there are two cases to think about. The first case is what we are going to talk about here, in which we are talking about when we know sigma. Sigma represents the population standard deviation. Now, in reality, in practice, it's rare to know the population proportion. Okay, that means you have a lot of information about the population. Okay, so usually that's not what happens, but we're going to talk about it here. And the scenario that usually happens, which is the one where you don't know sigma, we're going to talk about that in the next video. Okay, but in this video, we're going to estimate the population mean when we know sigma, which is the population standard deviation. So if you want to figure out how old state students are on average, what do you do, or how do you go about estimating this, right? So one estimate you can do is like this. You take a sample size, okay, sample of n students, okay, maybe 30 students, 35 students, whatever sample size you can take. Okay, you take a sample size, n students, and then you will find the average age of the students in your sample, x bar. And then you can say, well, I took a sample of 50 students, and the average age in my sample was 27 years. So therefore, I am assuming that the average age of all state students is 27 years. Okay, but you see, that has a problem, because if somebody else takes another sample, even a carefully chosen sample, the average age of all state students will probably not be 27 students, or will not be 27 years. It will probably be a little bit different from 27 years. Okay, so many samples taken will yield so many different averages. So which one do you use? Okay, so because of that, it's not a good idea to use what you call a point estimate, which is what you would have done if you take a sample of size n and you find the average age of all the students in that sample, and you say that the population average is that thing you have found. That is called a point estimate. And like I just explained a few seconds ago, the problem with that is that any sample chosen, even carefully chosen sample of the same size, will yield a different population. It will yield a different sample average. Okay, and so there is a dilemma: which one should you use? Because of that, it's better to use what you call an interval estimate. In which case, you are going to be doing something like this, which we all do. You know, you say something like, how fast were you going? I was going around 80 kilometers an hour. Around 80 kilometers an hour. Or how old are state students? State students are around 25 years old on average. Around. That's an interval estimate. You heard the expression give or take, right? Give or take a few years. That's an interval estimate. All right. So point estimates are not the way to go. The way to go is to use an interval estimate. And that's what is done when you are trying to estimate the population mean. This interval estimate is also called the confidence interval, which is what we are trying to do here. We are trying to create a confidence interval to estimate population means and population proportions. So If we assume that we know sigma, which is the population standard deviation, and we are choosing a sample of size 30 or more according to our central limit theorem, or if we know that the population is normally distributed, okay, in which case n can be any size, okay, then we can create an interval estimate for the population mean using this formula here. X bar plus or minus z multiplied by sigma divided by the square root of n. That's what we're going to use. Okay, the z in that formula is called the critical value, and I'm going to show you how to find that. Of course, you know that x bar is the sample mean, sigma is the population standard deviation, and n is the sample size. Furthermore, this z is the critical value that corresponds to what you call the confidence level, 1 minus alpha. Whenever you are talking about creating a confidence interval, you are always giving the confidence level. That confidence level is in percentage, and we will represent it as 1 minus alpha. So we can calculate alpha once we know what that confidence level is. And alpha is always a small number, okay? A small percentage is what that would be. So it's the error range, which we are going to see when we do examples. So for the z that I talked about just now, we are trying to figure out what that z is. The z has to correspond to the area that is the confidence level that you are talking about. So since the distribution is normal, right, according to the central limit theorem, your confidence level is the area 1 minus alpha. Okay, so 1 minus alpha is the space, the unshaded space in my picture over here, right? And your alpha split into 2 by symmetry, right? One of it is to the right, the other is to the left. The z-score that we're talking about is the z-score that corresponds to half the area, 1 minus alpha. Okay, so half the area, 1 minus alpha, it will be this space that you have. Okay, so the unshaded space divided by 2. All right, you are going to find the z-score corresponding to that using our z tables that we have been using previously. And then we are going to create a confidence interval using our formula here. So for example, let's do a quick example. Suppose a random sample of 47 SAIT students have an average age of 23 years. If the population standard deviation is 4.5 years, estimate the population average age using a 95% confidence interval. In other words, we want to create a 95% confidence interval estimating the average age of all SAIT students. Like we said previously, what we are doing is creating a confidence interval. Confidence interval is always point estimate plus or minus error estimate, as I've shown here right now. Point estimate is sample mean plus or minus the error estimate, which is z sub alpha over 2 times sigma divided by the square root of n. According to our question, excuse me, we have all this information. X bar is the sample mean, 23 years. Sigma is the population standard deviation, 4.5 years. N is the sample size, 47. We need to know z sub alpha over 2, which is the z-score that corresponds to the confidence level. Confidence level is 95% according to the question. And we said that is 1 minus alpha. So that's 100% minus alpha. That is your confidence level is 95%. If you rearrange that equation, you will find that alpha is 5%. That alpha is the area in the tails of your normal distribution, which if you split in 2, you will get 2.5 for each side. So the picture you have in mind looks like this. You can see the area in the tails is 2.5%, and you have 47.5% between the mean 0 and your z-score. So in your table of values, your z table, if you look for the area 0.4750, which is 47.5%, you will find a z-score of 1.96. So you should do that. You should check your table of values, your z table, and look for 0.4750 in your area, and then read that back to your z scores. You will see that it's 1.96. That is our z sub alpha over 2, which is our critical value. Using that critical value now and all the other information that we have, we can now create our confidence interval. X bar plus or minus z sub alpha over 2 multiplied by sigma divided by the square root of n. If we substitute all the information from the question in the formula, it will come out as shown, and then you can calculate your error is 1.29 years, and then you will have an interval of 21.71 to 24.29 years. So the population mean age of all state students, the average age of all state students, according to this question, will lie between 21.71 years and 24.29 years. What is the meaning of this? What this means is that we are 95% confident that the average age of all state students lies in the interval 21.71 to 24.29 years. A 95% confidence interval means that the process that's used to create this interval is accurate at 95%, which means that when you use this process to create 100 estimates of the ages of state students, 95 of those estimates you have made will contain the actual population mean, which is a pretty decent estimate, if you ask me. Okay, that is how you create a confidence interval when you know the population standard deviation. Now, I would like you to try one example by yourself. So, what you should do is, you should please pause this video now and try your hand on this example, and when you have finished, you can continue the video to see what I have done. So, please pause the video now. So, what did you do? Here's what I did. So we are trying to create a confidence interval. Sorry, we should read the question. A candy company wishes to estimate the number of candies in its packages. A sample of 120 packages produced an average of 18.72 pieces. Assuming that sigma, which is the population standard deviation, is 0.8735, construct a 99% confidence interval to estimate the mean number of pieces per package for the population. To do this, we are trying to create a confidence interval. The formula for confidence interval looks like as shown: x bar plus or minus z sub alpha over 2 multiplied by sigma divided by the square root of n. The information in the question states that the sample mean, the 120 packages that were picked, the average number of candies in them is 18.72. The population standard deviation is provided as 0.8735, and the sample size is 120. Now, the confidence level for this question is 99%. So that means that half of 99% is 49.5%. Okay, percent. So that's what you have in this picture here. The area in the tail is 0.5%, okay, because you have 99% confidence level. That means alpha is 1%. If you split that in two, you get 0.5% in each of the tails. So the z-score that corresponds to 49.5% is 2.575. Maybe in your own calculation, maybe you use 2.57 or 2.58. You know, that's okay for now. But because 0.4950 in your normal distribution, your standard normal distribution table, you don't have that in there. What you have is 0.4951 and 0.4949, I think. Okay, it's what you have. You don't have 0.4950 exactly in there. Okay, so because of that, you will use the average of 2.57 and 2.58. So that's why I have 2.575. So if you use all that information now in your formula for confidence interval, it will look like this. And so your error will be 0.21. So if you add those together, you will get a confidence interval of 18.51 less than mu less than 18.93. What this means is that we are 95% confident that the population average number of candies lies within 18.51 and 18.93 candies. That implies that if you use this same process to create 100 interval estimates for the number of candies, average number of candies that these guys are producing in this company, 99 of those estimates created using this process will contain the actual population mean number of candies that they are producing in that company. This ends our lesson for 8.1. Our next video will be 8.2.